Hey guys, this is going to be a tutorial video getting you started with Module 1. So what these videos do is they go through the notes and examples in your notes packets for Algebra 1. So I'm just going to start with our very first lesson, essentially. I have already filled in the notes part. This you guys will be doing in class with your teacher. But if you miss class, this is a great chance to make up the notes. Or you can always get them from your book. So you'll see up top is the name of what the lesson is about, as well as the section in the book that it's from. So you can always use your book to help with the notes as well. Or you can pause the video and copy them down. I'm going to go through the examples using the definition and rules that we've written down. So in this section, we're going to be adding and subtracting real numbers. This is going to include our integer operations as well as fraction operations. So when we are adding or subtracting numbers with the same sign, you always add those two numbers together and keep the sign. So something that's really helpful with this is knowing that subtraction is the same as adding the opposite or adding a negative. So I like to rewrite mine that way so that I always know addition, I'm just adding the numbers and keeping the sign. So 6 plus 6, both positive, so 6 plus 6 is 12, I'm keeping the positive sign. Negative 8 plus negative 7, add the two values, so 8 plus 7 is 15, and I'm keeping it negative. So as long as I'm adding two with the same sign, I'm keeping the sign. Now when they have different signs, we're essentially using subtraction, and we're always going to keep the sign of the larger number. So here, 12 minus 4, again, if you want to rewrite that as 12 plus negative 4, that's fine. So I'm going in the negative direction 4, plus negative 4, sorry, minus 8, getting ahead of myself here. So 12 plus negative 8 is another way I can write that. So when I am adding the negative, I'm going in the negative direction 8 spots, which is going to get me to a positive 4. So you can always think 12 minus 8 is 4, 12 is the bigger number and it's positive, so my answer should be positive. Again, I could rewrite this one this way, 8 plus negative 12. Okay, different signs. So again, I can think 12 minus 8 is 4, but this time the bigger number is negative, so my answer must also be negative. Negative 15 plus negative 7, well, that turns into our rule from up above. I have two negatives that I'm just adding together, so I'm going to get 15 plus 7 is 22, and I'm keeping the sign. Here, this is where a lot of people find this example a little bit confusing, but if you remember this piece of information, that subtraction is the same as adding the opposite. So instead of subtracting negative 4, I'm adding the opposite of negative 4, which is just positive 4. So anytime I have that double negative next to each other, it's actually going to turn to addition because subtraction is the same as adding the opposite. And then negative 5 plus 4, so 5 minus 4 is 1, and then my bigger number is negative, so it's going to be negative 1. Okay, so there's kind of some integer rules for you. Now we're going to do a quick review of our fraction operations. Okay, so here I have our rules for adding and subtracting fractions. So the biggest thing to remember with adding or subtracting fractions is that they have to have a common denominator. So how we find a common denominator, LCM stands for least common multiple, which means a number that they would both go into evenly when multiplied. Once I figure out what that number is, I'm going to multiply each of my fractions to get them to have that common denominator. Then we're going to add or subtract whichever operation is, the numerators, keeping the denominator the same, and then we're going to try and reduce or simplify if we can. So let's go ahead and try that with this example. So what I always like to look at is my two denominators. Whatever the bigger one is, I first like to ask myself, does the smaller one fit into that? Meaning, can I multiply 3 by anything to get 18? And in this case, I can. 3 times 6 is 18. So that just means I need to multiply this whole fraction by 6 to get it to have a denominator of 18, and then they would match. So I'm going to do 6, and I'm multiplying both the top and the bottom by 6. The reason for that is because I'm really just multiplying by 1. 6 over 6 is 1, so I'm not changing what it's worth. I'm just going to change what it looks like. So 6 times 1 is 6, and 6 times 3 is 18. So now, after this, I have 6/18 plus 5/18. Once I have a common denominator, then I can add the numerators. 6 plus 5 is 11. I keep the denominator the same. And then to reduce, we see, is there a common factor? Is there a number that I can divide out of 11 and 18? And they don't share a common one. So that is simple as we can make it. Okay, this one we're going to apply that same rule. So 4 and 6. Well, 4 doesn't go into 6 evenly. So I'm going to have to multiply both fractions in this case. So I want the smallest number, the LCM, that they both go into evenly. So the smallest one I can think of is 12. So I'm going to multiply this first fraction by 3 to make that 4 be a 12. And I'm going to multiply this fraction by 2 because I want to make that 6 be a 12. So I got to multiply both the top and the bottom by 2. Okay, so after I multiply that, I get 9 over 12. And I'm going to change my subtraction to adding the opposite. Okay, so now that I have a common denominator of 12, I can do 9 plus negative 10, which gives me negative 1. Keep the denominator the same, and I can't reduce that any further, so that is going to be my final answer. Okay, number 9 here, I have some mixed numbers. So there is a note here that if you see that a mixed number, we want to change the mixed number to an improper fraction before we follow our adding or subtracting rules. Another thing is if we're adding or subtracting an integer with a fraction, we can always change the integer to be a fraction by writing it over 1. So quick refresher on how to do that. We take the bottom, the denominator, times the whole number, and then add the numerator. So 5 times 2 is 10, plus 3 is 13. So this is 13, and then you keep that denominator and keep whatever sign it was. Same thing here, so 10 times 2 is 20, plus 7 is 27, and then keep that denominator. And then I'm going to add the opposite here. Okay, so now I need a common denominator. I cannot add these right now. So 5 does go into 10, so that means I'm just going to multiply this one by 2. So I'm going to do times 2 on the top, times 2 on the bottom. So I get negative 26 over 10 plus negative 27 over 10. I don't have to change that one. It already has a denominator of 10. Negative 26 plus negative 27, let's see, that's negative 53. And you guys, we're looking out here. I don't think we have to simplify this one either. All right, so there is one more thing we're going to talk about in this section, 1.2, and that is absolute value. Okay, so absolute value, our definition here is how far away a number is from 0, and we always measure distance using positive values, so after you take the absolute value of something, it should always be positive. They are these vertical brackets, kind of like parentheses, but not curves. So if you think about order of operations, we're always going to do what's inside our grouping symbols first. Absolute value are considered grouping symbols. So when I'm asked to find the absolute value of negative 4, that is asking how far is negative 4 away from 0. So if I imagine a number line, 0, negative 1, negative 2, negative 3, negative 4, so how far away is it? Well, it's 1, 2, 3, 4 units away. So the absolute value of negative 4 is 4. The absolute value of negative 10, you can imagine the same thing. Negative 10 is going to be 10 spaces away from 0. Now, in this instance, number 12, we have an operation going on inside the absolute value, so I want to do that first. So negative 5 plus 3 is negative 2, and that's still inside those absolute value brackets. Now that I've simplified inside as much as I can, now I'm going to ask the question, how far is negative 2 away from 0? It is 2 units away from 0. Okay, here, this is saying 2 times the absolute value of negative 3. Again, we want to do the grouping symbol first. So the absolute value of negative 3 is 3. So now this just becomes 2 times 3, which is 6. Absolute negative absolute value of negative 5. You can also think of this as negative 1 times the absolute value of negative 5, and the absolute value of negative 5 is just 5, so we evaluated that part first. Negative 1 times 5 is negative 5. All right, guys, that is it for the notes and examples for 1.2. Thanks for watching.